Logarithm. We have considered indices in our previous class. Now we want to consider logarithm. For the logarithm too, we need the laws of logarithm. Now the first one is this: log a raised to power n is equal to n log a. What this thing means is that if you are given a number, this is how logarithm will look like. So this one we call it number, and this one we call it the base. Now if you are given a number that is having if you are given log of a number that is having a power, the law says we can bring the power to the back like this. You can bring the power to the back, so it will be n log a. So e.g., let's say we have log 3 raised to power 5. The law says I can bring this 3 to the back so that it will become log 5 log 3. That is that. Another one says log a base b raised to power n is equal to this. What this thing means is that if you're having log a base b and the base is having the power, unlike this one that it is the number that is having the power. If the base is having the power, you can as well bring this power to the back. But when we bring the power to the back, it will be reciprocal 1 over n. So for instance, let's say you have log 2 base 5 raised to power 4. So the law says this power here, I can bring it to the back so that it will become 1 over 4. But assuming the 4 is on this, it will just be ordinary 4. So this is log 2 base 5. That is that. Another one, log a base b will give me log a divided by log b. So we should take note of that. So that is that about that. Let's assume you have log 3 base 2. So this is the same thing as log 3 divided by log 2. Another law there, if you have log a base a to be equal to 1. So for instance, you have log 3 base 3 to be equal to 1. This law holds if a is not equal to 1. That is, we must not have log 1 base 1. So it is not equal to 1. So we can only have it from a is greater than 1. So a is greater than 1. That is, a runs from 2 and above. So that is, if you have log 2 base 2 is equal to 1, log 10 base 10 is equal to 1, and so on and so forth. And another one, we have log ordinary 1 into any base at all. Log 1 into any base, the answer is 0. So let's take note of this. We still have more. We have this 6 and 7. If you have log a base plus log b, if they both have the same base, it's same thing as log a times b. If you have log a plus log b, so for instance there, we have log 2 plus log 3. So the answer will be log 2 times 3. That is what it means. That is log 6. So let's say you have log 5 times plus log 2. This will simply give me log 2 times 5 or 5 times 2. That is log 10. But if it is minus, it is division. Log a divided by b. So for instance, you have log 10 minus log 2. This will simply give me log 10 divided by 2, and that is log 5. So if you have log 4 minus log 2, this will give me log 4 divided by 2, and that is log 2. So let's take note of all these laws of logarithm. Let's write them down and memorize them. We shall be using them once again. You have it here. You have it. Number 3. We still have more. So we'll be unveiling it as the lecture goes on. Let's take an example. We want to simplify the following. The first one, we have log 8 base 2. What we need to do here is we need to write out the index of 8, which you have given before. Index of 8 will give me 2 raised to power 3. Then, according to the first law of logging that I give, we can bring this 3 to the back, so that it will be 3. And I've taking the 3 away, it will remain log 2 base 2. And don't forget, we have said log a base a in this place is 1. I said log a base a is 1. So in that case, this 1 here is equal to 1. So we are going to have 3 times 1. So our answer is 3. So the answer to this is 3. So another question, we want to simplify log 3 base 81. So we don't know the index. This one has no index, but this has index, which is 81. 81 has index as 3 raised to power 4. So in this case, by the law of logarithm, I can bring this power 2 to the back. But since it's on the base, it will be reciprocal. That is, it will be 1 over 4 log 3 base 3. So this will be equal to 1 over 4. This whole thing is 1. So it's 1. So it will just be 1 over 4 times 1. And that is 1 over 4. So for the third one, we want to simplify this. Log 16 base 32. So we only need to know the index of 16, which is 2 raised to power 4. The index of 32, that is 2 raised to power 5. Now both this and this have base. If I can, by the law of logarithm, I can bring this base, this power to the back, so it will be 4. Also, I can bring this power 2 to the back, but if I bring it to the back, it will be over, it will come under, just like what we have here. As you see here, when we brought the power to the back, it comes under. So if I have taken these 2 away, it will remain log 2 base 2. And log 2 base 2 will give me 1. This will be 1. So our answer is 4 over 5. So that is that about that. Let's take another example. So I have log square root of 27 into base 9. 9, the index of 9 is 3 square. This is square root of 27. The index of 27 is 3 cube. Now, this will still be equal to, this is 3 squared. This, from what we explained in indices, we said square root means power, power into fraction. So in this case, this will be 3 raised to power 3 divided by 2. The square root means power of over 2. Now, by the law of logarithm, I can bring this to the back. So it will be 3 over 2. I can bring this one 2 to the back. Let's say it will be times, if I bring this 1 to the back, it will be 1 over 2. Then log 3 base 3. And log 3 base 3 is 1. What we have left is 3 over 2 times 1 over 2. This is 1. So it is gone already. So our answer would now be 3 divided by 4. That is 3 times 1, 3. 2 times 2, 4. So 3 over 4 is our answer. Another example, I have log 4 base 2, this base this, and this base this. You can do it in 2 ways. You can do it one after the other. Follow our rule. We know that 4 is same thing as 2 squared. The index of it is 2 cube minus index of 16 is 2 raised to power 4. By law of logarithm, this can come to the back, so to become 2 log 2 plus this can come to the back to be 3 log 2 base 2. This one too can come to the back, it will be 4 log 2 base 2. Now, log 2 base 2, this is 1 plus 3. This is also 1 minus 4. This is also 1. So this will give me 2 plus 3 minus 4. And 2 plus 3 minus 4 will give me 1. So that's our answer. That is one method. Another method is by using the number 6 law of number 6 and number 7, which says when you are adding two logarithms, you multiply the powers, but when you are subtracting, you divide the you multiply the numbers, and when you are subtracting, you divide the powers. That is, log all this will become, since they have the same base, you can only do that when they have the same base. So let me write the same base. Now, since this is plus, it will be 4 times 8. 4 times 8. This is minus, it will be division, divided by 16. So this is now log 2. 4 times 8 is 32. 32 divided by 16 is 2. Then log 2 base 2 will give me 1. So that's our answer. So when you are giving addition in logarithm, you multiply the numbers, and if it is minus, you divide the numbers. Let's take another example. I have this example here. Now the first thing is, let's write the ones that we can write the index. Let's write the index out. This is, firstly, you observe that the bases are not the same thing. So since the bases are not the same thing, we cannot apply the law of addition and subtraction. And let's write, so in that case, we need to write them out one by one. Index of 27 will give me 3 raised to power 3. Index of 4 is 2 squared, while index of 8 is 2 cubed, plus, we have given this in our first video. Index of 625 is 5 raised to power 4, while the index of 125 is 5 raised to power 3. So by law of logarithm, this one can come to the back, so it will be 1 over 3, then log 3 base 3. By the law of logarithm, these two can come to the back, the power. This power here, but it's on the base, it can come to the back as well, but it will be over, it will come to over, then log 2 base 2. Now there's power on this, it will come to the back, it will be 4, but the power on this one, when it comes to the back, it will come under, then log 5 base 5. So we know that this one is 1, so it will become 1 over 3 left, minus this one is 2 over 3, this one is 1, so our answer is just 2 over 3, because 2 over 3 times 1 is still 2 over 3, plus this is 4 over 3 as well. So they have the same base, so we can just operate on the numerator. That is 5. This is 1 minus 2, plus this will be 1 minus 2 plus 4 all over 3. And this will give me 3 divided by 3. And 3 divided by 3 will just give me 1. So 1 is the answer. So let's move to another example. Before we go to that example, let's take note of this law or this relationship. The law says that if you have log A base B is equal to C, if you have this type of relationship, that logarithm is connecting these three things, A, B, C. A is on top, B is at the base, and C is outside. Then the law says that A is equal to B raised to power C. A is equal to B raised to power C. It will let us to solve the following questions. Example, log S base 2 is equal to 4. Now this is representing my A, this is representing my B, this is representing my C. So the law says our answer is X this is equal to this raised to power this 2 raised to power 4. Then S is equal to 2 raised to power 4 will give me 16. Another one, I have log S squared base 9 is equal to 9. This is representing my A, this is representing my B, this is representing my C. The law says it will be this A, this equal to this raised to power this 9 raised to power 9. Sorry, it is 2, so it is 9 raised to power 2. From that place, you see that 2 cancels 2, then S is equal to 9. So S is equal to 9 is our answer. Another one, log 243 base s is equal to 5. By the law of logarithm that we have just seen here, a, b, c, a is equal to b raised to power c. That is this, the up one is equal to the down one raised to power the outside one. That is just the idea. Now, by the index, the one I've given you before, 243 will be 3 raised to power 5. You write out the index of 243, and this is s raised to power 5. From that place, 5 cancel 5. All you have left is s is equal to 3. That's our answer. So another one, log s plus 1 base 2 is equal to 3. So by what we said the other time, the up one is equal to the base raised to power the outside one. We know that 2 raised to power 3 will give me, that should give me 8. Then s is equal to 8 minus 1, and that is 7. So s is equal to 7. So another one, log s is by 3 plus 1 base 3 equal to 2. We want to find the value of x. So by the law of logarithm, we are going to have the up one, everything here is the up one, s cubed plus 1 is equal to the down one raised to power the outside one. So therefore, we have s cubed plus 1 is equal to 3 square will give me 9. Then, if you collect the like terms, s cubed will be equal to 9 minus 1. So s cubed will be equal to 9 minus 1 will give me 8. And finally, we know how to solve this. We just need to find the index of 8. That is 2 raised to power 3. So 3 cancel 3. Then s is equal to 2. So s is equal to 2 is our answer. So let's consider another one. So we want to find this log this minus log this is equal to 1. So Adimbin is only one thing, just like this. We will have said the up one is equal to the down one raised to power the outside one. But we have two things here. So we have to make them one. How can we make them one? We use the law of logarithm, the number 7, which says the minus will turn to division. So that is this thing, it will be 3s plus 2 over 3s minus 2. So that is for this. Then it will be equal to 1. So we have turned these two to 1 with the help of law of logarithm. So from that place, we have the up one, the base, and the outside one. So our answer will be 3s plus 2 over 3s minus 2. The up one is equal to the base raised to power the outside one. Now let's cross multiply. So we have 3s plus 2 equal to, this will multiply this, 2 into 3s minus 2. So if you expand, we have 3s plus 2 equal to 2 times 3s, that is 6s minus 2 times this, that is 4. So we collect the like terms now. I'm taking this away to this place, and I'm taking this minus 4 to this place. So if I'm taking this away, it will remain minus 2 left. Let me bring minus 4 to this place, it will become 4. I did not take this away. If I bring this one here, it is plus 3s. So it will become minus 3s. So 2 plus 4 will give me 6. 6s minus 3s will give me 2x. Then s will be equal to 6 divided by 2. And that is 3. So s is equal to 3 is our answer. Sorry, there's a mistake here. 6s minus 3s is 3s, not 2s. So our answer is s is equal to 6 divided by 3, and that is 2. So 2 is our answer. So 2 is the solution to the question. So let's consider another one. We have another one here. Log this base 3 plus that is equal to this. So here we have two things as well, but we have to merge it together. We will use the law of logarithm, which says this addition will become the multiplication of this. That is s plus 1 into 3s plus 3, which is equal to this 3. So the whole of this will now be the up one. This is the down one. This is the outside one. So the law says the up one, this is the up one, is equal to the down one raised to power the outside one. Now let us expand. This is 3 here. Let us expand. S times this, we have 3s squared plus s times 3, we have 3s plus 1 times 3s, we have 3s plus 1 times 3, we have 3, equal to 3 cube will give me 27. So this will give me 3s squared plus 6s, 3s plus 3s, 6s plus 3. When this one comes here, it becomes minus 27. So it's equal to 0 left. So this is 3s squared plus 6s. 3 minus 27, that is minus 24. It's equal to 0. You observe that 3 is common to all of this. So if I divide both sides by 3, I'm going to have, if you divide this one by 3, this one by 3, this one by 3, this one by 3, you are going to have s squared left plus, if you divide this one by 3, you are going to have 2x, 6 divided by 3, that is 2, minus 24 divided by 3, that is 8, is equal to 0. So this one leads to quadratic equation, and thank God we have considered the solution of quadratic equation. So you need to solve it. When we solve it, you should get s is equal to minus 4 or s is equal to 2. But we are dealing with logarithm, so minus 4 cannot be the answer. So in that case, this is an answer. S is equal to 2 is the only solution. So the minus cannot be the solution, because if I put minus here, minus 4 plus 1, that is minus 3. So we cannot have log of negative number. Does not exist. So the only one that exists is this positive one. So s is equal to 2 is the only answer.